All right. Okay, guys. So question 1.1. Okay. Hopefully you've obviously got the question up in front of you. It says in a particular area, 75% of the people have been vaccinated against COVID-19. It says further known that 40% of the vaccinated had a previous infection of COVID-19 and 60% had a previous infection of COVID-19 of the unvaccinated. Person is selected at random, given that the person has had a COVID-19 infection, determine the probability that this person will be vaccinated by using a tree diagram first of all. So the trick is, I guess, to figure out, do you do the vaccinated first or the previous infection first? And intuition, I guess, would say, well, previous comes before, but actually it's not the case here, because in the question, it says 75%, that's not the important bit, have been vaccinated. The important thing that gives you a clue which direction to go in, it says that it is further known that 40% of the vaccinated had a previous infection. So what they're saying to you in probability language is, given that they were vaccinated, probability that a previous, I'm going to say PI for previous infection, was equal to 40%. It's not common for them. What that means is, we've got to start, in order to use this information on the tree diagram, we've got to start with the given first. Given that they're vaccinated, probability that an infection was 40%. So what is given has to go first on the tree diagram. So what am I talking about? Well, you've got to have whether it's vaccinated or not vaccinated first, because of that information they gave you over there. Right, so they told you 75% of the people had been vaccinated. So vaccinated is 0.75. You could work with percentages. Not vaccinated is 0.25. Okay. Then they said, given that they were vaccinated, the probability that they had a previous infection, or the probability that they didn't have a previous infection. So they said, given that they're vaccinated, the probability that they had a previous infection was 40%. So this over here is 0.4, which means that this over here is 0.6. Okay. So it's further known that 40% of the vaccinated had a previous infection. 60% of the unvaccinated had a previous infection. So previous infection was 60%. Unvaccinated would have been 40%. Okay, sorry, not having a previous infection. So that's your tree diagram. But that flows in this direction, from vaccinated to previous infection. The question, however, says this. Okay, the question is asking you, given that the person has had a COVID-19 infection, in other words, a previous infection. So they say, given that the person has had a previous infection, okay, what is the probability that they were vaccinated? So that's what the question is asking. Given that the person has had a previous infection, okay, determine the probability that they've been vaccinated. This always goes first. So now we're going from previous infection to vaccinated. So we're going in that direction from previous. So we're going the wrong way around on the tree diagram. Okay. And in that case, with conditional probability, we're going to have to use a formula. Okay. So we want to work out the probability of V given PI, which is going to be equal to the probability of V and PI of the probability that you had previous infection. Sometimes in the question, they'll give you the denominator. Okay. In this case, they don't. Okay. So probability of vaccinated and a previous infection, okay, is this vaccinated and previous infection, is that over there. So it's 0.75 times 0.4. Okay. And the probability of a previous infection, okay, is this in yellow. It's that there. That's a previous infection, a route to a previous infection. And that's also a route to a previous infection. Okay. So that'll be equal to 0.75 times 0.4 plus 0.25 times 0.6. Yeah. And if you put that into your calculator, you should get an answer of 2 over 3, which you're going to either leave as 0.66. In this paper, it's always 4 decimal digits, so you could leave it like that, or you could leave it at 66.67%. Okay. So if it's in the wrong direction, so first of all, when you set up the tree diagram, if they give you something about conditional probability like they did here, They gave us this has to go first before infections, right? If we're then going in the wrong direction, also check your mark allocation. We can't just redraw the tree diagram. We have to go use the formula. Right, next question is quite unusual. Let's try and make this a bit smaller. In that they want us to set up a contingency table, but normally we do them with just numbers. Now we're doing them with probability. It's quite a very nice question, actually. So they said now go work out the same thing, but by using a two-way contingency table. It doesn't matter which goes on which axis. So this is for question B. So the two conditions we're looking at, is vaccinated, not vaccinated. We need totals. And then we're going to have previous infection, not previous infection, and total. That total now is probability. Total probability. So your table will be something like this. And the only thing at this stage I really know that I can fill in on the table is that I know that the total probabilities have to add up to 1. Okay. So, now how can I fill in these spaces? Well, what does this space over here represent? This space represents the probability that somebody's been vaccinated and had a previous infection. And vaccinated and previous infection is this over here. So that's 0.75 times 0.4. And if you work that out, you put that into your calculator, you get an answer of 0.3. Okay, so I've got 0.3 in that space over here, right? Okay, then, I also know, they said to us in the question, it said in a particular area, 70% have been vaccinated, 75% have been vaccinated. So I know that this must be 75%. So 75% have been vaccinated. Okay, so this is 0.3 and that's 0.75. 0.3 plus what gives you 0.75? That must be 0.45. You could also figure it out vaccinated and not previously infected by going vaccine 0.75 times 0.6. It will give you 0.45. Okay, but what else did they tell us? Okay. Sorry, so in the next question, they say to us, okay, so sorry, 0.3, 0.45, 0.75, that's one. So that's one. Okay, this over here must be 0.25 because that's the total thing not vaccinated. Okay, is equal to 0.25. Right, now to figure out the other amounts. Okay, so this space over here represents not vaccinated and previously infected. So not vaccinated and previously infected will be this part over here, 0.25 times 0.6. And if you work out 0.25 times 0.6, you're going to get an answer of 0.15. So that's 0.15, that's 0.25. So that must be 0.2 because 0.15 plus 0.2 is 0.25. And if we add these up, 0.3 plus 0.15 is 0.45. 0.45 plus 0.2 is 0.65. And then our test is, does this add up to 1? Yes, it does. Okay. So those are values over here. Here's our contingency table. And now, once again, they wanted the probability that somebody, given that they've had a previous infection, what was the probability that they were vaccinated? And again, we're going to use our formula. Probability vaccinated and previously infected over probability of previously infected. And vaccinated and previously infected is the space over here of 0.3. And previously infected works out to be 0.45. And 0.3 divided by 0.45 gives us the same answer, 2/3 or 0.667. Okay. Right. Hope that all made sense.